Okay, so this is probably the main part of the talk, really. So can you just hand these out? Most of the time you go to a talk about climate change, people talk about it within the frame of the Paris Agreement, which is like keeping things under 2 degrees centigrade, the heat increase. Everyone presumably knows about this. And they'll talk about carbon budgets and what have you. And a few people who are on the radical end of those talks will talk about this slightly embarrassing thing about the climate change agreement, which is that it depends on taking carbon out of the atmosphere. And it's this thing called BECCS, where they grow food, grow green stuff and then burn it and stick the stuff under the ground. And they point out that it hasn't actually been tested and no one knows whether it will work at scale, so it's a little bit risky. But what I'm going to talk about is what's actually happening. So the assumption is this is the Paris Agreement here, and the climate change problem is more or less coincidental with it. But I'll show you in about 2 minutes that it's not really the case, assuming you agree with my 3 basic principles of arithmetic, consistency, and what have you. All right, so this, I've watched about 200 videos on climate change, but after about 10, you sort of get the general gist. It's not good. And I'm a bit autistic, I've got to admit. So I sort of look at, you're hearing a presentation and I'll come out with something and you go, that's quite interesting. Right, and then you'll just carry on talking about things that aren't that interesting. So you have to sort of use your attention a little bit. Where's mine? So here this is this objectively, I'm going to stick my neck out and say this objectively is the most important graph in the world. I think it's probably the most important graph in the history of humanity. It shows what's happening to the ice. So in 30 years, it's gone from what you might call full cover to 25% of the cover. So the idea is that it's going to hit 0 in the next few years. Now, if I was like a 13-year-old science student, I'd be able to work that out, I think. This doesn't take a lot of thinking about, does it? I don't know. I'm really hoping someone's going to prove me wrong, but I'm sort of looking at this. It's like there's a little bit of noise in the system, but ice melts when it's warm, and 25% still to go. And you follow the graphs down, and if you're a very clever mathematician, you can work out whether it's going to be 2019, 2020, 2022. But let's say, for the sake of argument, it's going to be ice-free by what, 2024, give or take, which isn't that far off. So what does that mean? Well, if you see the full graph, you can see the ones in January. It's all over the internet, so presumably it's from all these ice institutes. If you look at the rest of the ice is going to be gone within 10 years after that. Now, if you do listen to some of the major professors and supposed intellectuals of the world, and you ask them when the ice is gone, they say like 2030 or 2050. I don't quite know why, or at least that's a deeply psychological issue. I heard a woman last week say it was 2030. Anyway, it's not. It's going to be 2022, isn't it? Because we all can just look at the graph. It's a basic physical system. It's not complicated. Okay, so that's interesting. So something leads on from that, which seems to be fairly clear, which is this thing called a latent heat effect, which is just as sort of basic physics as ice melting when it gets over 0 degrees centigrade. And it goes something like this, that once the ice has gone from the ocean, it doesn't reflect the heat back into outer space, and it becomes dark because the water is darker than ice. That seems fairly straightforward. And then it soaks up more heat. So it's like what's called a positive feedback cycle. So I'm interested in the numbers because a lot of the discussions, and if this was a normal climate talk, someone would say, and that's dangerous. Well, I'm interested in how dangerous, let's give us the figures. So you look in the scientific literature, so it's 0.5 of a degree centigrade increase in global temperatures, which is obviously, so the logic is, this is the ice, it's definitely going to melt, I'm going to say 99% certain, and that's going to lead to a 0.5 degree increase in global temperature average. So that's interesting. And then something else they sort of tell you in the small print is that the carbon, the CO2 that they put in the atmosphere is a lot of it has yet to come through. So we're at the moment we're at 1.2. So we know it's going to go up in the next 10 to 20 years by 0.5. That seems like more or less definite. And then there's the CO2 that hasn't actually come through yet. So again, you sort of mention this as a little issue, but it seems like fairly like massive, doesn't it? That there's still stuff come through. So again, what is the figure? Well, the figure is 0.5 apparently. So that's sort of basic arithmetic, aren't we? I'm just a simple numbers person here, and thousands of scientists around the world are involved in a process that doesn't really seem to accept what we've got, which is we're already above 2 degrees centigrade. That's already locked in. I mean, I could talk about all the other variables, the things that there's a 20% chance that it's going to be 8 degrees higher in the next 5 years. But I don't really need to do that. I'm just trying to show you what is absolutely certain. This is absolutely certain if I understand basic physics and if we agree with basic arithmetic. And then there's this thing called water vapor. So I checked that out again this week. So apparently, like every degree that the world increases in heat, you have to add on another degree because the water, you've got more evaporation, and that goes up into the atmosphere and creates more heat. So in theory, we should be adding on another 1. And then, if you look in the scientific literature, it seems that if we go over 3, then the Amazon's going to burn down. It seems fairly clear. Maybe it's 2.5, maybe it's 3.5, who knows? But it's somewhere in that region. And then that's going to add 1.5. So, okay. So, this is before we've actually thought about what humans are doing. So I don't know. I just read this stuff, right? I don't know if it's true. Have you read this stuff? Please prove me wrong, but this is all scientific literature stuff. It's basic physics, right? And then a bit more basic physics is that this is the average temperature increase. But it's also basic physics that the centre of continents warms up twice as fast as the coast. So if we get over 2, that's going to make it 4, right? That's 2 times 2. So at 4 degrees, basically you can't grow grains in the centre of continents. So you can look this up. It's in the literature, like grain, like corn. The productivity of corn decreases by 15% every degree centigrade increase. So if it's 4 degrees, you're looking at 60% reduction in corn production. The whole literature on civilizational stability and sustainability is based upon the notion of storable grains. That's basically how they grew up. But you don't need to be a genius to work out that if grain production falls on average by 50%, obviously there's going to be lots of variability, then we've got a major problem. And we're looking at this, in the next 10 to 15 years? So again, looking in the scientific literature, and it appears there's been 5 major extinctions in the historical record. One of them was caused by a meteorite, but the rest were caused primarily by CO2 coming out from volcanoes and by methane coming out as well. But the upshot of it is it's actually quite straightforward. So basically, you've got this ball called the planet, and it's got ice at both ice caps. And when it melts, there's this positive feedback. And so when you've got ice knocking around, it's usually about that sort of temperature. And I think we're 13.5. And when there's no ice, it's at 23 or thereabouts. So it sort of makes sense. You have this like flipping, because obviously once all the ice is melted, then the feedback's finished. So you've got like a hot Earth and a cold Earth. So you can see that once this flips, it's not that complicated. It flips into ice and it flips back out of ice. So once it's at 23, in the record, paleo record, it shows that up to 95% of the life on the Earth has died. And the reason they think this is the case is because of this thing called nitrate sulfide, I think it's called, sulfide.
Is it nitrate what?
Nitrate sulfide. I think that's right. I can give you some references at the end. So basically what happens is there's no wind because there's no difference in temperature between the equator and the Arctic. And so the oceans become stagnant, a bit like a stagnant pond. And this nitrate sulfide stuff comes out and basically affects the air. And if you're a mammal, you can't breathe properly and you die. And if you're a reptile, you might get away with living. And then it also affects the oxygen because the phytoplankton dies after 6 degrees above what we are at the moment. And that affects oxygen levels. So at the moment it's like 25%, I think, but it can go down to 12 in the historical record. So this is basically like why all higher living mammals die during these great extinctions. So that's what we're heading towards.
Is there any negative feedback loops?
Strangely enough, apparently not, that are only significant. I've just told you about 3 or 4. I've just selected out the ones which are dead certain. There's actually 69 of them in the scientific literature. So we could, for instance, I could talk about methane. Methane is super scary, but it's not certain. They don't know when methane is going to come out of the permafrost. If you're not aware, methane, there's lots of methane in the permafrost. It's trapped because it's icy, and then it melts and the methane comes out. So if 1% of the methane comes out, that's a 0.5 degree increase in global temperatures. So you don't need that much to come out. And it only takes a year for that to happen, by the way.
I thought there had been these mass deaths of elks or whatever, that deer or whatever.
Yeah, it's coming out at a rate of knots. Yeah, that's right. Well, that's slightly different. Okay. I mean, it was 700 parts per billion. See, I've done my homework for this talk. 700 parts per billion in 1800, and it's 1,800 now. So it's going up exponentially. You can look at the graph. So it would be a reasonable prediction that it's booming up towards the point at which there's going to be a big release of methane. And most of the paleo scientists think this is the reason that triggered the mass extinctions. But I'm being super conservative because no one's actually said, it's not hard physical science, right? It's like a probability analysis thing, which is why I showed you that thing. But the pathway I've shown you is, unless you want to question the arithmetic or question basic physics, that's what's happening. The latent heat effect is done and dusted. The ice melting is done and dusted. The carbon that's yet to come through is done and dusted. Do you see what I mean? So that sticks us into 2 to 3 degrees centigrade. So we've got a number of interesting situations there. Okay, we're going to have a break in a minute, but I don't know if this is going to be helpful, okay? There's a number of different things. So when you're doing, when one or two of you who are better than me do this talk, you can decide whether this is useful. But when I was a kid, I used to play Monopoly a lot. In fact, I'm a bit of an expert on Monopoly. I played it like every Sunday for 10 years. And I sort of worked out the maths. And it's actually really boring when you've worked out the maths. But there's something quite interesting about Monopoly. I'm going to do a sort of simple Monopoly thing here. Okay, so everyone's played Monopoly, hopefully, yeah. So you go around, you buy various properties, yeah, and then once you get set, you can put the houses on, and then you can charge people lots of rent. And what the interesting thing about Monopoly, mathematically, is everyone starts off even, don't they, with £1,500. But mathematically, within 3 hours, you can absolutely guarantee there's only one person left. So why is that? Well, what we sort of know is that I'm doing a simplified Monopoly here. You've got one person with 2 houses here and the opponent with 2 houses there. And you might say it's 50-50 chance for these 2 people to win, right? But then someone lands on this house, let's say that's Mayfair. And if you've ever landed on Mayfair, you know it's not good news. So you lose a house because you've got to pay the rent, right? So you might say, well, you've still got a house left. So to start off with, you've got a 50-50 chance of winning. And I don't know what the odds are, but once you've got only 1 or 2 houses and the other guy's got 3 or 4, it's not looking good, right? I mean, you could more or less scrape back because they could land on you twice. But let's say, for sake of argument, it's 10 to 90, let's say, right? You're just about out of the game if you do the maths. I mean, your ego's probably holding on that you're going to win. And then you land on Mayfair again and you lose the other house. And so you've got no houses now. If you're familiar with Monopoly, once you've got no houses, you haven't got any way to get back. So the chances of you winning then are something like this. I don't know whether that's true, right? It could be 1 in 100 million, it could be 1 in 1 million. What we know is you're fucked. You know, you're not going to win because they've got to land on you, about 100 times before you can afford a house, and you've got to not land on them every time you go around, right? So this is like a positive feedback system, which basically predicts that someone will totally win. And the analogy with the climate is, once you've sort of triggered a feedback, then it exponentially increases. Do you see what I mean? Now, what's interesting when I play this with my 6-year-old is when this happens, he can't really cope, and he just like runs out of the room in a tantrum, because psychologically he thought he was sort of winning, and then he lost half his houses, and then he's sort of wiped out. And he's too fast. He emotionally can't really cope. So this is an analogy of our society at the moment. We're sort of like at 50-50. But we're heading towards 1090, and in 30 years' time, there'll be a mass nervous breakdown because it's going to be game over, right? I mean, I'm just doing the maths, right? It's just like this is... Another analogy is pushing a ball down the hill, right? If you kick a ball down a hill, there's a certain point at which you can run and catch it, right? But at a certain point, it's going to keep speeding up. This basic physical law, right? So once you get past about here, it's gone. So we know the Earth system flips, right, between 12.5 and 23. So the thesis is once you've pushed it past 2, a lot of people argue once you've passed it past 1. I mean, we pushed it past 1, but there's 2.5 still in the system. You're up to 3. And then you're speeding up so fast that it's off and away.